All right, we are moving on to volume of rectangular prisms today. So we worked with surface area yesterday, and that is a little bit of the trickier of the two formulas. Surface area was what we did yesterday down here, where we were basically adding all of the 6 faces of the figure up, but because you had 2 faces that were opposite each other that would have the same area, that's why we had this 2 involved in this formula. We took the length and the width of one side to find the area of it and doubled it because there's another side of the same area. Same for length times height. We doubled it, and width times height. Today we're moving on to right here, which is our volume formula. As you see, it's much simpler. In fact, some people yesterday, I noticed on IXL, if you were struggling with it, a lot of people were actually finding the volume for the surface area problems because the only questions that you would get right were the ones where the surface area and volume happen to be the same number, which can happen occasionally. Just depends on the numbers you're working with. So if you struggled yesterday, I will be doing the meetings on Friday through the Blackboard Collaborate, so you can use the link that I sent to your email before break. I'll probably just be posting them as well on Blackboard in case you had trouble accessing your email. I think that was an issue for some people. But you'll have those designated time slots, 9 o'clock for first block, 10 o'clock for second block, and 11 o'clock for third block. Okay, that way, if you are having questions with maybe surface area or anything that we do this week, you can pop in and ask me those questions and I can walk you through the problems. I'm also going to be adding in some extra hours where we can have that live Blackboard time next week, because that's when you guys are going to start doing your performance assessments that you'll be turning in. So to get started with volume, we have to make sure we understand the difference between volume and surface area because they mean different things. So for volume, that is the volume of a three-dimensional figure is a measure of capacity. So that's what I'm going to fill in here first. So capacity is like how much fills up inside. So like if this rectangular prism here was like a fish tank and I wanted to see how much water I could fill up completely inside of it if I filled it up to the brim, that's a measure of capacity as opposed to the surface area, which was just on the outside. So I'm filling something. Now to find volume, what you're doing is you are taking the base or the bottom's face of the rectangular prism, and it is comprised of, if you look at your base and this one, I'll switch colors real quick so you can see better. This is your base down on the bottom here, okay? And that is comprised of the length and the width, okay? So when you are finding the base, we're going to multiply the length times the width in order to find it. And then, and that's two-dimensional right there. And then you need to take that base, which is the length times the width, and you need to add that dimension, that three-dimensional part, which is right here. So you're going to see like how many times basically you can stack up the base on top of itself to reach the top of the shape. So you take the base, which is the length times the width, and then you multiply that by the height to give it that third dimension. Okay. Volume is measured in cubic units because of that. So that means when I write my answer, I might have maybe instead of like a squared symbol or a 2 as an exponent, maybe it's millimeters cubed. Okay, so you have a 3 as your exponent, or inches cubed. Or you could write, instead of inches cubed, you could write cubic inches. You could write it out like that, or feet, or whatever your units is that you're working with. Okay. So the formula, again, it's the base times the height, but because the base is comprised of the length times the height, excuse me, the length times the width, and then you multiply the height, basically a simplified version is right here. The volume is equal to the length times the width times the height. So you literally just multiply all three of the numbers that make up that three-dimensional figure, basically, the three dimensions. So you could see examples would be maybe in this truck over to the side here, you would be, if you wanted to see how much space was inside this truck, to see how much stuff you could fill up inside of it, you would just multiply those three dimensions together. Same thing for this little cube. Yes, it's a cube. All the length, width, and height are the same. You just multiply all three of those together. All right, so moving on, I'm going to do 3 guided examples like this and then a couple more word problem scenarios, and that'll be it because volume is pretty straightforward, basically. So for the first example, I have a rectangular prism. You have to decide what you want to be the length, width, and height. It gives you the 3 values. You just have to decide what you want to be what. The values don't appear multiple times in the formula like they do for surface area, but we still want to make sure we know which is the length, width, and height. So I'm going to say that the length will be the 3 inches in the front here, so my length will be 3. My width will be the 5 inches kind of front to back, and that would make my height the 6 inches tall that this figure is going. So the formula is that volume is equal to length times width times height. Now on your formula sheet, you do not see the multiplication symbol in between the length and the width and the height, because when you have 3 variables, or even if it was 2 variables next to each other like that, it indicates multiplication already. So now I'm going to substitute in the dimensions, right? So the length we said was 3. Now I cannot just put 3 and then a 5 for the W, then a 6 for the height. It's not 356, right? You have to show multiplication somehow, whether you do that little X for that multiplication symbol or the dot. It really doesn't matter. You can use parentheses to show multiplication, but you have to show somehow that you're multiplying. It's not 356. So remember, just as a side note, okay, the 3 times the 5 that was right here, that was your base. So that was the area of this part right here. And then we basically wanted to stack that on top of itself all the way up that 3rd dimension through the top of the shape to see what our total volume is, okay? So the base would have an area, of, that would be 15 inches squared, right? But then we want to, again, this is 3-dimensional, and we want to now add that height as that 3rd dimension. So 3 times 5 times 6, you multiply all those together, or you take the 15 that was the base and multiply it by 6. That would give you a volume of 90, and this would be inches cubed. So the difference between surface area and volume as well also is with your units at the end. Surface area, your units are squared. Volume, your units are cubed. Because surface area, though you're looking at a 3-dimensional shape, surface area itself is really 2-dimensional. It does not have a 3rd dimension. It's just the area of a bunch of faces added up together. An area is 2-dimensional. Because there's only 2 numbers you're multiplying together, basically. If there's 3 numbers you're multiplying together, it's 3-dimensional. You can kind of think of it that way. All right, so my next example, I have, I'll switch colors here so they don't all run together. I need to decide, again, my length, width, and height. I will go with 2 for my length here. The width would be 3. That's how far back it looks like that shape is, and then the 4 would be the height. So length is 2, width is 3, and height is 4. So the formula is that volume is equal to length times width times height. I plug in my values. So my length, this time I'll use parentheses. 2 times 3, again, that's my base right there. The 2 times the 3 right here, which would be 6. So I'd have an area of 6 feet squared. But then I also multiply it by the height, which is 4. So when I multiply all of that together, 2 times 3, of course, this part right here that's your base would give you an area of 6 feet squared for the base. But then I go ahead and add that height into it. So I multiply the 6 times the 4, which gives you 24, this is feet cubed for my final answer. And again, you can just type all that in your calculator all at once. 2 times 3 times 4, you'll get 24. You just need to do feet cubed when you label your answer. And the last example I have on this screen, the 5 meters, the 8 meters, and the 8 meters, it's not a cube because not all of the dimensions are the same. 2 of them are the same. My length right here will be the 8 meters. My width will be the 8 meters. And the height will be the 5 meters. So my formula, volume is equal to length times width times height. I'm going to multiply those numbers together, so it would be 8 times 8 times 5. 8 times 8, of course, gives you 64. So again, that's your base right there. I'd have an area of 64 meters squared for my base, and then I'm also multiplying that times the 5 meters tall that this is, and that would give you a volume of 320 meters cubed for the volume, because again it adds that third dimension of height. So volume is pretty simple. You're literally just multiplying the 3 numbers that make up the 3 dimensions of that shape together, and make sure that you put a cubed symbol or an exponent of a 3 for your units at the end, and that's it. Pretty easy. All right, so now we're going to work through this problem on our own, kind of like you would if you were doing your IXL practice. The formula is not given to me. It doesn't break it down as much step by step. I have to pull the formula from my formula sheet. So if I'm solving for the volume, I know the formula is that volume is equal to length times width times height. I need to decide what I want to be what. So I will make this 6 meters right here, the length, the 2 meters, the width, and the 3 meters, the height. So when I plug those values in, I would have 6 times 2 times 3. Again, this right here is my base, so I'm finding the area of that. So 6 times 2 would give me an area of 12 meters squared for that base. And so the base area is equal to 12 meters squared. And then I finish off that formula by also making sure I take into account the height. So I'm also going to multiply that 12 times the 3, or you just do 6 times 2 times 3 all in your calculator at once. Will give you an answer of a volume of 36 meters cubed. So again, it is important to note that if you were to find the surface area for this shape, it would be different than the area. Every once in a while, you just run into a problem where the numbers happen to work out and they can be the same, but most of the time they're going to be completely different. So again, the area it's a 2-dimensional calculation, which is why your units are squared as opposed to cubed, but it's a 2-dimensional calculation of a 3-dimensional shape. So it's just, again, adding up all of the 6 faces of the shape. The volume is seeing how much space can fill up the inside of that shape. So the volume is 36 meters cubed. For this last question, we have a word problem, basically. It tells you to find the volume, so I know that's what I'm doing. But again, in the problem, it also gives us some hints as well that we are finding volume if it didn't ask us for that specifically. So it says a sandbox is 1 foot high, 4 feet wide, and 6 feet long. So we'll make note of what our length, our width, and our height are over to the side. It tells us in the problem, but again, it's kind of easier if you just pull those numbers out. The length is actually listed last, so that's 6 feet or 6. The width is in the middle here, the 4 feet wide, so 4, and the height is 1 foot high, so 1. So my volume formula, again, is just length times width times height. I substitute in these values, so 6 times 4 times 1. Well, 6 times 4 is 24, times 1 is still 24. So the volume is 24, this is feet cubed. And there you have it. Pretty easy.